All right, and hi everyone, and welcome back to the final part of our note packet in Unit 8. So as you can see, we're still in Target 23. We're finding perimeter, we're finding area, but this is going to be our last part, Part 5. And today is about composing and decomposing two-dimensional figures. And so what this means is like finding area and perimeter of things that are like combo shapes, or where we have this bigger shape and we've taken some other shape out of it, for instance. And so we're going to have to like combine the area or perimeter of multiple things here. And so let's start just real quick by defining what composite figures are. And a composite figure is just a combination of two or more figures. So again, that's like what we just talked about, right? We're going to put two figures together. One's one shape, one's a different shape. And for us to find like a total area, for instance, we find the area of the one shape, find the area of the second shape, and then add the two together. And so you'll see that here. Now, one thing I will mention to you is this is not a long section of notes by any means, only 6 problems. However, there's a lot of work that goes through this, and we're going to try to keep it organized as well. And I know I generally don't do a great job of that. I'm gonna try to do my best job possible here to make it, make it make sense to you. So here we go. We have a composite shape here in number 1, and we want to find the area of that shape. And so here's what our composite shapes are. If I kind of extend this line here and see how these marks mean all of these sides are the same. And if all of them are the same, this bottom one is also going to be the same as the top one. And so this bottom shape here, and I'm going to get rid of it in a second, but I'll highlight it in a color right now so we can visualize it, assuming, okay, my pen is not working. I'm not allowed to change colors. Interesting. Give me a second, everybody. Got it. All right, so here we go. Here's our two shapes. The one in red, because all 4 sides are the same, is a square. So I'll write that over here. We need to find the area of the square. Now, the shape in green is kind of like a circle, except for it's a half circle, which matters, right? And so I'm going to write that here, half circle. Now, in this problem, those are the two things we need to find the area of. We're going to find the area of the square, we're going to find the area of the half circle, and we are going to add them together. All right, now one more time, I want to reiterate half circle, and we'll talk about dealing with that in a second. But let's start with the square. All right, let's start with the square. And so what I want you to see here, as I erase this and just make it a little bit more clear, is that again, if we extend this line, right, that's like an entire side of our square. That top is going to be the same as the bottom. Well, it's also part of our circle. And so this 4 is the radius of our circle. It goes straight through the center and then to the other side. So if the right side's 4, the left side's 4, meaning that whole line there is 8, right? Now, that'll apply to the circle in a second, but right now we're talking about the square. And so if that top side is in total 8, then all other 3 sides are 8 as well, because a square, all sides are the same. And so if we want to find the area of a square, it's going to be, right, base times height or side squared. And so in the base times height kind of way, right, we can say 8 times 8. So 8 times 8, and that is simply just 64. Now, obviously there are units here. I'm going to hold off on the units until I get to the final answer, and then I'm going to put them on. So this is definitely 64 square inches. We'll worry about that in a second. Now, I'm going to clean up the picture again, and we're going to go to the half circle, because we already have the square area. Now we need the circle area. And so again, if I clean this up, well, I can write 8s here still, but here we go. Now, remember when I turned this into a diameter before, that helped me figure out the length of the side of a square. But I don't need to do that anymore for the circle, right? Because the area of a circle, oh, I should change it to green. The area of a circle is pi r squared. And so we have to have the radius. So we don't want the diameter. But remember, radius is half the diameter, And so that's exactly what this is. Our r is just 4. Now, I've circled and I've arrowed half circle, right? This formula here is going to give us the area of the whole circle. And so what we're going to want to do is, let's type that in, pi times 4 squared. But when we get that answer, we're going to divide it by 2. And that way it becomes the half circle. So pi times 4 squared, right? Pi times 4 squared is going to give us, oops, come on, calculator. Not working at all. There we go. Clear it. Come on. All right. I'm just going to reload that calculator program real quick. Thank you for your patience. Obviously, this is cutting into our video time a little bit. I think it'll still be okay. We should be able to get done with this part, I think, in 2 videos, hopefully. So here we go. Ooh, there we go. It's working now. So we need to type pi times 4 squared. So second pi times 4 squared. But remember, pi r squared is the whole circle. So the whole circle is 50.3, we'll say. But then, remember, we want half, and so that'll equal 50.3 divided by 2. So we want to go back to our calculator and just hit divided by 2. And so the area of half the circle looks like 25.1, right? 25.1. Now, we are not done yet either. I'll underline that because now, remember, our shape was the square and the half circle combined. And so our total now will be us taking our 64 from the square and adding the 25.1 to it. And so let's go back here. There's our 25.1. If we just hit plus 64, now we've got our total, and it is 89.1. 89.1. Now, we'll bring the units, inches squared. And there we go. There we go. So that's the idea. You got to visualize the shapes, and then you either add them together or subtract them, but you do each one separately, right? And when I said, or you subtract them, here's what I mean. Here's a problem where we'll subtract. We want to find the shaded figure, right? And so this big rectangle is shaded, but then there are 2 white rectangles in the middle of it. Since they're white, we are going to subtract them away. We're going to subtract them away. And so here's what I'm going to do. I'm going to call the shaded rectangle A. Rectangle A is our shaded figure. And so let's just find the area for that. And an area for a rectangle, base times height. And so for the gray rectangle, that's 60 times 24. And so when I do 60 times 24, I am going to get 1,440. Now I'm going to underline that because I need that for later, right? That's the area of the big rectangle, but it is not the answer yet. Now I'm going to put a B into that one and a C into the other one. We need to find the areas of those 2 rectangles as well. And then since they are not shaded, we will subtract them away from our shaded total, right? And so rectangle B, I'm just going to abbreviate rectangle B, that's going to be 15 times 10 for the area. And that should be 150. Now you'll notice rectangle C is the same size, 15 base, 10 height, right? So the area is going to be the same, 15 times 10, which is 150. Now, one last time, right, we're going to get to the total real quick. And our total this time has to be a subtraction. The big rectangle is 1,440, and then we want to take away the white rectangles B and C. So we'll minus 150, that'll take away the rectangle B, and then we'll subtract 150 again, which will take away rectangle C. And so our total will be 1,440 minus 150 minus another 150. So it's kind of like subtracting 300, right? And so our total will be 1,140. And then let's bring the units in, feet squared. And there we go. Excellent. All right, let's move to this one. In number 3, I hope what you see is we have a big circle, and then we have a little circle in the middle. And the big circle is shaded, but the little circle is white. And so we need to find the area of the big circle, and then we're going to subtract away the area of the little circle. And so let's keep our work consistent, right? So big circle. Oops, that was spelled wrong. Now it's right. Now remember, area of a circle is pi r squared. And so we have to figure out what's the radius of the big circle. Remember, radiuses always start from the center, and then they go to the edge. So what number starts from the center and goes to the edge of our biggest circle? That's 4. So the radius of the big circle is 4. So we're going to type pi times 4 squared. And when we type pi times 4 squared into our calculator, second pi times 4 squared, we're going to get 50.3. All right. However, we're not done. So that fills up everything here. But we need to take away the center, the little white circle, right? So we'll call that little circle or small circle or whatever, circle A, circle B. Let's go. And so again, this is still a circle. So the area is still pi r squared, but now our radius is different. And so if we clean this up a little bit, remember radius always starts from the center. And so what's the distance from the center to the edge of the white circle? Just going to be 2. So for this little circle, our radius is 2. So we want pi times 2 squared. And when we type that into our calculator, we will get pi times 2 squared. When we type that into our calculator, we get 12.6, let's say, 12.6. And so now we have these two numbers, big circle, little circle. Remember, we have to subtract the little circle because it's not shaded. And so our total is just going to be 50.3 minus 12.6. And that will equal, if we go to our calculator, we can just go up and highlight the 50, hit enter, and then minus, and go up again, highlight the 12, hit enter again, and you will see 37.7 roughly. 37.7 and inches squared. All right. Let's keep moving forward. We got about 2 minutes left here. We'll set up this next problem. Oops, I hit the share button. Go away. Go away. Let's go full screen. Now, this problem's a little hard to picture. It's a little hard to figure out what shapes these are, right? This is a weird looking one. And so I want to try to help you visualize this. Imagine this. Imagine you could see this drawn. Now what does it look like? Now to me, this shape kind of looks like it's a rectangle, right? And then we've just subtracted out these 4 almost circular corners, right? And so I think that's where we want to start this problem. We'll call it a rectangle. We'll call our shaded region a rectangle. And so what we'll do is we'll find the area of this rectangle. And then we need to subtract away these 4 circular corners. Now, a couple things here. We're not ready to find the area of the rectangle yet. Area of the rectangle is base times height. But the only problem is we know the height, it's 6. But this base, if I kind of erase this bottom part, that 6 is only this piece. We need to know how far are these 2 pieces for us to figure out what the actual base is. And so we're going to start doing that here in the next video. So stay tuned.